Hey everyone, welcome back to Tutoring. So today we are going to be doing a tutorial video on Chapter 70, Question 3, B, D, and G. So a lot of questions today, but they should be relatively short. Hopefully I can fit them all into a 10-minute video, right? So these are the harder questions. If you haven't watched the topic video on how to anti-derive using trigonometric identities, make sure you check the topic video first. This one we're going to dive into much harder questions compared to the examples I gave you in the topic video. So let's get into the question. First one, I'm going to do D first, and then B later, and then G, just so that it flows well, okay? So let's have a look at part D. We are going to anti-derive cos to the power of 4x in terms of x, and this is a definite integral, so you got power 4 and 0 as well. Okay, first of all, the first thing that comes to mind is this is an even power function, so that's 4. 4 is an even number, it's an even power. So whenever you see an even power, what do we remember? If you recall from the topic video, you have to use your double angle formula. So that is the cos 2x equals to 2 cos square of x minus 1. This is also in your formula sheet, so if you get, make sure you check that out, or make sure you just take a quick look at your textbook or your formula sheet, and then you'll remember all of this back, okay? But cos 2x equals 2 cos square x minus 1. I'm gonna make cos square x by itself, so make it the subject. So that is cos 2x plus 1 divided by 2. So that was what we did in the previous video. The problem with this one now is it's cos to the power of 4. We only have cos squared. So it's only logical that if you want to get cos to the power of 4, you square both sides again. Because if I square the left-hand side, square over square is 4. And therefore, yes, that's fine. I'm just going to square the right-hand side as well. So, okay, this is going to take a little bit of a while. I'll do it quickly. Cos 2x plus 1 squared. 2 squared we know is 4. Cos square of 2x plus 2 cos of 2x plus 1. So a squared plus 2ab plus b squared. And then, yes, everything divided by 4. And then, okay, we cannot anti-derive yet because, yes, this is almost there. We're going to replace cos 4x with this. But we still cannot anti-derive, and the reason why is that cos squared 2x messed things up, okay? So once again, if you want to get rid of the square, we want everything to the power of 1, okay? You can only anti-derive trig functions that are to the power of 1. So if you want to be able to anti-derive this, I'm going to move it a little bit to the left. We convert the cos square into the power of 1, and to do that, same thing here, okay? So instead of having cos 2x, now I'm going to use the cos 4x equals to 2 cos squared. So it's still double angle formula. I'm just going to use the double angle formula once again, but this time instead of 2x is 4x, but it's still double, okay? So that means cos square of 2x is equals to cos 4x minus plus 1 divided by 2. Right, I'm just going to replace everything here again. So cos square x with cos square 2x with this, and we get cos 4x plus 1, everything divided by 2. And then plus 2 cos 2x plus 1. I know it looks a bit messy, but don't worry, it will simplify very nicely towards the end, okay? And what is that equals to? I'm going to bring the 2 over to all of them. So that's cos 4x plus 1 plus 4 cos of 2x, and then plus 2. So I bring the 2 up. And then everything will be divided by 2, but then you also have it divided by 4, so the 2 can just come down and you get 2 times 4, which is 8. And let's just add everything up first. That's cos 4x plus 4 cos 2x plus 3, and then everything divided by 8. And there we go. That is what the cos to the power of 4x is equals to. And then once you get up until this part, guys, all you have to do is just anti-derive, okay? So which implies that, let's see, this is pi on 4, 0 being your terminals, pi on 4 and 0. And then you can just bring the 1 and 8 out, and we're just going to anti-derive this normally, okay? So cos 4x plus 4 cos 2x plus 3 in terms of x, and you can start anti-deriving, okay? That is 1 on 8. Cos 4x, as we know, positive cos becomes positive sine when we anti-derive, not negative sine. Just be careful. Make sure you don't get these confused. And always have the 1 on 4, so you derive the inside and then you divide. Same thing over here. Cos 2x becomes sine of 2x, same function, but then you get the derive the inside, which gets you the 2, but then you divide, so it's half. 4 times half is 2, and it's a plus again. And then the 3 just becomes a 3x, okay? And then you're gonna have to sub in pi on 4 and 0 because this is a definite integral question. So a little bit on the long side, but we can definitely do it. 1 on 4 times by sine of 4 times pi on 4, that is sine of pi, and we know what that becomes, but I'm just going to write everything first. 2 times pi on 4, that is pi on 2, plus 3 pi on 4, so I've just pretty much subbed in pi on 4 into everything, that's it, okay? And then it's minus, you sub in 0 into everything. We know that if I sub in 0 into 1 on 4 sine of 0, you just get sine of 0 is 0, so this becomes a 0, so that's fine, it's minus 0. And then same thing here, if I sub in 0 here, I get sine of 0 is 0, 0 times 2 is still 0, so that's fine, it's still 0. And then 0 into the 3 is 0, and you can see why my favorite number is 1 and 0 in this course, because 0 just becomes 0, it's such a nice number. But let's expand everything. So what is sine of pi? Sine of pi is -1, is 0 actually, not -1, cos of pi is -1. Sine of pi is 0, so that just becomes 0. Sine of pi on 2, on the other hand, is 1. 1 times 2 is 2. And then you have plus 3 pi on 4. The 0, you can just ignore that. And there we go. Our final answer is 1 on 4 plus 3 pi on 32. Okay? That is our final answer when you sub in pi on 4 and 0, or when you find the definite integral of this function right here. Okay? So that's part D. It's very long, but that's why it's a good question. That's why I wanted to do in this video. Okay, and then moving on to the next part, I'll skip B, I'll move B to the next video, and then we'll move to G so I can keep this video so that it's not too long. So we'll do G, and then I'll do B, which is quite big, into a next video, okay? So let's have a look at part G. So we're anti-deriving definite integral once again, but this time you have an even power function and then another even power function. So if you have even power and even power, what do? It's a bit different, right? In the topic video, we had even and odd, and you focus on the odd. But when you have even and even, obviously you have to focus on, one of the evens, right? Okay, and to do this, guys, so you just rewrite this whole thing again, but you can replace one of them. So I'm going to replace sine square with 1 minus cos square, so identity rule. 1 minus cos squared. Don't be tempted to use double angle formula, and that's because there's two functions. So you always want to get into one function first. Identity rule, 1 minus cos squared is the same as sine square. If you expand this, you get cos square of x minus cos to the power 4 of x dx. And then there we go. This is an even minus an even. You can just separate them out, okay? So if you want to write this function in terms of two integrands, you have pi on 3, 0, cos square of x dx minus pi on 3 to 0 as your definite integrals, and then your cos is now to the power 4 of x dx. And yes, this would have been very long had I not done the first part. So if we look at this, pi on 3, 0, cos square of x, what's another way of writing cos square of x? Well, we have to take a look over here. Cos square of x is cos 2x plus 1 divided by 2. So that is cos 2x plus 1, and anti-derive in terms of x. We bring the half out. And then same thing over here with the cos 4 of x. What's another way of writing that? Well, let's take a look at what we have. Cos 4 of x is the same as over here. So I'm just going to take the simplest one, the one that I can find. Cos to the power 4 of x is this cos to the power 4x is this massive equation right here. So we take the 1 on 8 out, and I'm just going to copy what we did, okay? So cos 4x plus 4 cos 2x plus 4 cos 2x plus 3 anti-derive in terms of x, and there we go. So that is our integrand, okay? So when you have sine squared, cos squared, even power function, use your identity rule, convert into one type of function, and then you can use your even power function rules, okay? Right, anti-deriving this, well, I mean, hopefully after this point, we should be pretty comfortable doing this. Positive cos, we get positive sine. So positive sine 2x, I derive the function in the inside, which gives me 2, and I divide it, and then the 1 right here becomes an x, and then we just have to sub in pi on 3 and 0. Okay, same thing on your other term. So cos 4x becomes a sine 4x positive, because if you derive positive sine, you do get positive cos. And just make sure, bring the 1 and 4 out. Same thing over here. We already done this before, sine 2x, and then the 2 comes out as a half. 4 times half is 2. and the 3 becomes an x, so that's 3x, and then we sub in pi on 3 is 0. Okay, afterwards, all you have to do is just sub in numbers. I'll do it quickly here. That's half sine on 2 pi on 3 plus pi on 3. The good thing with the 0 is you sub in 0, sine of 0 is 0, and then everything just disappears. 0 also disappears, so you don't even have to sub in the 0, which is quite convenient. And then over here as well, 1 on 8. If I sub in pi on 3, that gives me 1 on 4 sine 4 pi on 3 plus 2 sine 2 pi on 3, and then plus 3 times pi on 3, it's just plus pi. And then of course you have the minus and then sub in the 0. But the good thing about 0 is you sub in the 0, it just disappears. Okay, sine of 0 is 0, 3 times 0 is 0, so you don't even have to write it, right? And then let's just do some simple trig. Half of sine, I'm just going to expand it over here, so half times half is 4. Sine 2 pi on 3, if you remember your trig from back then, 2 pi on 3 is in quadrant number 2 with a basic angle of pi on 3. Opposite is root 3, adjacent is 1, hypotenuse is 2. So therefore, sine 2 pi on 3 is root 3 on 2. Second quadrant, sine is positive, that's fine. There we go. Half times pi on 3, that's pi on 6. Minus 1 on 8, 1 on 32 actually. So rub that part out. So 1 on 8 times 1 on 4 is 1 on 32. Times by sine 4 pi on 3, so it's in the third quadrant instead. Same number, root 3 on 2, but this time you have a negative. And then plus 1 on 8 times, oh, that's actually a minus. And yes, I should put a bracket actually. Let's put a bracket. 1 on 8 times 2, that's 1 on 4, times sine 2 pi on 3, we know that is root 3 on 2 from here. And then of course 1 on 8 times pi is just pi on 8 with the bracket so that we don't get confused with the sign. Okay, 1 on 4 times root 3 on 2, that is root 3 on 8 plus pi on 6, and then it's minus 1 on 32 times negative root 3 on 2, that is root 3 on 64, but with a negative, so it's a positive root 3 on 64. That is pretty big, the denominator. Plus 1 on 4 times root 3 on 2, so that is plus root 3 on 8, but because there's a negative sign, I should really change that to a negative. And then excuse the messiness in this video, but last one, we're almost there, plus minus pi on 8. Okay, so the good news is the root 3 on 8 cancels out the root 3 on 8, and then all you have to do is just add your your pi's, and that's it. Pi on 6 minus pi on 8. What does that give us? Well, common denominator is 48. This is 8 pi, and that's minus 6 pi. And then we have the plus root 3 on 64, and we're almost done. This is 2 pi on 48, which is equals to pi on 24 plus root 3 on 64. Don't blame me, blame the question. It's meant to be this way. It's quite long, but there we go, guys. This is the answer for G. So that is chapter 7E, question 3D and G. We'll go into question B in the next video so that this video isn't too long for you. But aside from that, guys, hopefully you understand this part. We've done even function, we've done even and even power trig functions. Hopefully it's useful for you, and I'll see you in the next video. Thanks for watching.